Let's talk about simplifying radicals, right? We're all familiar with what this little symbol means, the square root of a number, right? We might know, for example, the square root of 4 is 2, or the square root of 9 is 3, or the square root of 121, for example, is 11. Why is that? Well, the square root of a number, or rad4 is a way to shortcut it, is basically just saying what number times itself twice gives me 4. Same thing here. What number times itself twice gives me 9? What number times itself twice gives me 121, right? 2, 3, and 11, respectively. But what happens when I'm given a number that doesn't have a perfect square root, right? Rad 20, that exists, but it's a decimal, right? Rad 20 is something like 4.4721, and it keeps going, right? How do we arrive at that number if we don't have a calculator specifically? Over here, I'm going to start a list of all the numbers after 1 that have a perfect square root, right? 4 does, right? Square root of 4 is 2. Let's just go up the ladder. I'm just going to keep climbing up a bit here. Right, we're all familiar with these numbers. We're going to use the numbers that have perfect square roots to help us make this a little bit smaller. So anytime we come across a problem like this, in which we're asked to find the square root of a number that doesn't already have a perfect square root, we're going to write right next to the square root two little placeholders. I need two factors of this number inside the radical, and one of those numbers has to have a perfect square root. That's how we can go about solving any one of these problems, right? I need to find two factors of this number, and one of those factors has to have a perfect square root. That's why it's very helpful to write out all the numbers that do have perfect square roots starting from 2. And just go up the list here. So what are some factors of 20 that are over here in the right-hand column? Do any of these numbers go into 20? Well, only one does, right? 4. So I'm going to write the 4 there. And then, well, 4 times what gives me 20? Well, 5. Okay, now we talked about how remembering one of these numbers has to have a square root, right? I'm not simply just going to be listing the factors of 20. One of them has to have a square root. Which one does? Well, it's the 4, right? We pulled it from the list. So what I'm going to do here is I'm going to then take the square root of that number and go ahead and throw it out front of the radical. And then I'm going to take the other factor, the number left over, and he's going to squeeze inside to replace the 20. So let's do that again. Let's take the square root of the number that has the perfect square root, right? The 4. Square root of 4 is 2. I get kicked to the outside, or the 2 does. And then the other number I found here just replaces the 20. So my answer becomes 2 rad 5. That's it. That's all you have to do. Now, you might have to ask yourself, well, can I simplify this any further? No, this is as far as we can go, right? 5's a prime number, so that's how you know to stop. The square root of 32 is a problem to solve. Okay, well, first step, does 32 have a square root? No, you might know that from memory, or if you need a recap, go ahead and write out the square root ladder. 32 does not have a perfect square root. So what are we going to do? We're going to draw our two little placeholders here, something times something, and one of these guys has to have a perfect square root. So let's go to our ladder here. Any of these numbers, are they factors of 32? Yeah, 4 works again. We can do that, right? 4 times what is 32, right? I believe that's going to be 8, if I remember correctly. Yes, it is. Thank you, Mr. Calculator. For arithmetic, I should know how to do right off the top of my head. Okay, which of these two has a perfect square root? The 4 does. 8 doesn't. There is no square root of 8 that gives me a whole number. So I'm going to circle the 4. And remember the 8 is going to go, or whatever that number is going to go inside. And the number that has the perfect square root is going to get kicked to the outside. So the square root of 4 is 2. Rad, the other number. Okay, now stop and ask yourself, can we go any further? Yes, we can, right? There are some factors of 8 that have perfect square roots. What do you think? 4 again, right? 4 times what is 8? 2. Here it comes. I circle the 4 that has the square root, and I'm going to take it to the outside. Okay, now you'll notice something here. We already have a number on the outside. So what do we do when we have multiple steps and we take out another number when there's already a number there? You're just going to multiply the two numbers together. So since there was already a 2 here, and I'm taking the 2 out of this 4, it becomes 2 times 2. 4 on the outside. And the 2 here, or whatever number that is, the outside number, gets kicked inside. It becomes 4 rad 2. That's it. Now, what you'll want to do is you'll want to pick a number that might work a little bit faster. For example, 4 definitely works, but watch what happens if we had picked 16, right? 16 does go into 32, and it'll be a little bit faster, right? Which of these have a perfect square root? 16. Square root of 16 is 4. Bring in the 2, 4 rad 2. So same exact math. One step took a little bit longer. So you're going to want to aim for the highest or biggest number on the square root ladder here as a factor that's going to help. Just get you to the answer a little bit quicker. Now, to think of this as the square root of 121 divided by 64, that's way too complicated. But we can split this up. So anytime you have a fraction in a radical, and the radical is housing both the numerator and the denominator, we can split it up. This is actually the same as saying the square root of 121 divided by the square root of 64. We can kind of split it up. Now, this is much more visually pleasing and easy. What's the square root of 121? It's 11. And what's the square root of 64? It's 8, 11/8. So 2 quick ways we can simplify square roots and radicals. Again, like all concepts, they do build on each other and they do get a little bit harder, and I'll be doing some more videos that explain that, but a definite good start at some of the basics. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and subscribe, and share it with a friend who might find this video also helpful. Thank you so much, and I'll see you in the next video.